Local AI infrastructure and model management. The persistent challenge of GPU memory management continues to drive innovation in the local AI community, with a small team of systems engineers proposing a novel approach to one of the most common frustrations: the 60-90 second wait time when switching between models on a single high-end GPU. Their prototype runtime uses snapshotting to capture a model's complete GPU and RAM state, enabling restoration in 2 to 5 seconds, limited primarily by PCIe bandwidth rather than model loading overhead. The community response reveals interesting divisions about whether this solves a real problem. Critics point out that for text-only workloads, maintaining one fast and one slow model through vLLM covers most use cases, and question who would run a 70B chat model alongside a 7B code model in 2026. The developers acknowledge this isn't for steady, always-on deployments, but rather for bursty traffic, development workflows, agent systems fanning across specialized models, and image-video generation pipelines where multi-model workflows are standard. Whether this scratches a real itch or addresses an edge case will likely depend on the GitHub release's reception. Meanwhile, the llama.cpp ecosystem gains another heavyweight with merged support for KXON, LG AI Research's ambitious mixture of experts model featuring 236 billion total parameters with 23 billion active during inference. The model brings notable features: a 256K native context window using a hybrid attention scheme, multi-token prediction enabling 1.5x inference throughput through self-speculative decoding, and multilingual support across Korean, English, Spanish, German, Japanese, and Vietnamese. For those confused about the llama.cpp versus LM Studio distinction raised in community discussion, llama.cpp is the open-source inference engine, while LM Studio is closed-source software that uses llama.cpp code under the hood. Security consciousness in the local AI space receives a practical boost with Veritensor, a new CLI tool for scanning AI models against malware and verifying integrity. The tool handles Pickle, PyTorch, and GGUF formats using stack emulation for malware detection, verifies file hashes against the Hugging Face registry, and flags restrictive licenses like CC by NC, addressing a real blind spot as users increasingly download models from varied sources. For those wanting to learn inference engines from first principles, a minimal 950-line implementation targeting the H100 demonstrates that building performant inference from scratch, complete with continuous batching, CUDA graphs, and quantized MOE, remains tractable for educational purposes. Open-weight model releases and performance. StepFund's Step Audio R1.1 has claimed the top position on the Artificial Analysis Speech Reasoning Leaderboard with 96.4% accuracy, outperforming Grok, Gemini, and GPT real-time on audio reasoning tasks. The model represents a genuinely novel architectural approach. Rather than treating speech as a simple input-output problem, it implements what the team calls mind-paced speaking through a dual-brain architecture, separating reasoning from speech generation. A formulation brain handles high-level reasoning, while an articulation brain manages speech output, allowing chain-of-thought reasoning to occur during speech generation without sacrificing latency. The technical innovation addresses what the researchers term the inverted scaling issue, the counterintuitive problem where reasoning over speech transcripts can actually degrade performance. Step Audio R1.1 grounds its reasoning directly in acoustic representations rather than text alone, using iterative self-distillation to make extended deliberation productive rather than detrimental. This enables effective test-time compute scaling for audio tasks. Deployment requires substantial hardware, tested on 4TinyL40S, H100, H800, H20 configurations, and a customized vLLM backend, but the weights are fully open. Community questions about voice cloning and multilingual support remain unanswered in initial discussions. The efficient model tier sees competition from Zhipu's GLM 4.7 Flash, a 30B A3B MOE model positioned as the strongest model in the 30B class, balancing performance and efficiency for lightweight deployment. The model supports vLLM and SGLang on their main branches, though installation currently requires nightly builds. Benchmark results emphasize multi-turn agentic tasks on Tala Bench and Terminal Bench 2, with recommendations to enable specific modes for those evaluation scenarios. Translation-focused models receive attention from Tencent's HYMT 1.5 series, featuring both 1.8B and 7B variants supporting mutual translation across 33 languages plus 5 ethnic and dialect variations. The 7B model upgrades the team's WMT25 championship model with terminology intervention, contextual translation, and formatted translation capabilities. Perhaps more practically significant, the 1.8B model delivers comparable translation quality to its larger sibling while supporting edge device deployment after quantization, potentially enabling real-time on-device translation without cloud dependencies. AI agents and orchestration systems. Research from the University of Central Florida introduces LAMAS, Latency-Aware Multi-Agent System, a framework addressing a fundamental gap in multi-agent orchestration. While existing systems optimize for task performance and inference cost, they fail to control execution latency in parallel environments. The paper systematically categorizes existing approaches and their limitations. Sequential adaptive methods like AnyMac and SeqCV model agent interactions as linear chains, but their strict sequential nature prevents exploiting task decomposition for parallel execution. DAG-based architectures supporting directed acyclic graphs theoretically enable parallelism, but their cost-centric optimization, using penalties like total token usage, implicitly assumes latency correlates with total inference cost. This assumption fails because these controllers favor narrow and deep topologies, minimizing node count rather than execution depth, leaving potential gains from wide and shallow parallel structures unexploited. LAMAS introduces explicit optimization for the critical path in parallel multi-agent execution. The insight is straightforward. In a parallel system, latency equals the longest sequential chain, not total computation. By supervising the critical path directly, the framework can trade increased total computation for reduced wall clock time when appropriate, the opposite of what cost-optimized systems produce. Static parallel methods like AFLOW and EvoAgentX operate at coarse task-level granularity, optimizing a single topology for entire datasets and lacking flexible per-query resource allocation. LAMAS addresses this by enabling query-adaptive orchestration while explicitly targeting latency, making it suitable for interactive assistance and real-time decision-making where rapid feedback matters as much as reasoning accuracy. Practical agent tooling advances on multiple fronts. An on-device browser agent demo shows Qwen running locally within Chrome, prompting discussion about whether improving small models combined with better edge inference hardware could eventually render data centers less critical for certain use cases. The team notes vLLM integration is coming pending bug fixes. For production agent systems, observability tooling built for traditional APM proves inadequate. Agents aren't single API calls, but multi-turn conversations with tool invocations, retrieval steps, and reasoning chains requiring distributed tracing across sessions, traces, and spans. Capturing context across async operations while handling high-volume traffic without killing performance remains the hard engineering problem. A web UI for agent monitoring addresses the dashboard side of this challenge. AI-powered creative and automation workflows. A detailed case study in automated illustration demonstrates the current state of multi-model creative pipelines, generating illustrations for Robert E. Howard's Conan story Tower of the Elephant, using Llama and Mistral for prompt generation, Qwen 3VL for image scoring, and various image generation models. The workflow raises interesting questions about quality control automation. Image scoring with vision language models provides a feedback loop for generation quality, but optimizing this scoring remains an open challenge. The author seeks community input on two frontiers: improving vLLM-based image evaluation and automating final image editing by using a vision language model with both the image and story text to prompt image edit models like Qwen Image Edit or Flux Klein. This represents the kind of complex multi-step creative workflow where agent orchestration research has practical applications. Memory systems for AI workflows draw a provocative critique, arguing that RAG, retrieval augmented generation, fundamentally misunderstands how working memory should function. The argument, RAG treats memory as a retrieval problem solved by embedding text into vectors and retrieving by cosine similarity, but memory is actually an attention problem. When debugging an OOM error, relevant documentation becomes salient not because of semantic similarity, but because of recency, temporal dynamics, and propagation from related concepts, none of which RAG captures. The alternative approach, hologram, models attention as a physical system with conservation laws where files have pressure values representing current attention, accumulating when mentioned and decaying over time. Relationship discovery happens automatically from wiki links and content rather than manual configuration. Benchmarks claim striking results. Manual configuration had 50% error rate with one of two edges referencing a non-existent file, while the automated system found 20 valid relationships that manual effort missed. The bounded total pressure prevents the everything is relevant problem plaguing RAG with large knowledge bases. Cross-ecosystem agent orchestration shows growing interest, with documentation emerging on using Claude Flow, the agentic toolkit, within Google's anti-gravity Gemini environment, rather than solely within Anthropic's Claude Code ecosystem. Community discussion reveals a pattern of using Claude for documentation and deep dives, while leveraging other systems for higher-level brainstorming and visualization, suggesting heterogeneous agent deployment across providers based on task characteristics rather than single vendor lock-in. AI safety and security concerns. A cautionary tale about Cowork, Claude's agentic coding interface, documents a near-miss data loss scenario that prompted one user to develop a comprehensive safety approach, treating the agent like a power tool, not a chat box. The sandbox approach involves creating a dedicated isolated folder /cowork sandbox / granting agent access only to that folder rather than home directories or document folders, intentionally copying files into the sandbox for risky operations, and using read-only symlinks when access without modification is needed. Aggressive backups during agent sessions, and forcing a plan-first step listing exactly what will be created, edited, or deleted, complete the protocol. The community response highlights a deeper concern. This manual implementation of safety controls should arguably be baked into infrastructure. One commenter asks whether operating with user permissions is even safe compared to running in a container the agent cannot escape. Others share war stories. One describes Claude going full Forrest Gump, making a mistake, then when instructed to roll back to a previous night's backup, instead writing the mistake over the backup file. The incident required building a utility for hourly backups with UI screenshots and change tracking. The consensus aligns with lessons from a widely circulated deletion incident. The real failure mode is permission scope creep, letting agents operate in high-value directories because it's convenient. Tools like Claude Code damage control that block or warn on risky commands represent community-driven mitigation. A different AI-assisted security experiment yielded more philosophical lessons about AI limitations. When faced with an HP ProBook laptop locked by a BIOS password, HP's enhanced security writes encrypted passwords to a separate flash chip, with official recovery requiring motherboard replacement. One experimenter tasked Claude to write a Python script for brute forcing via the Windows-based HP BIOS utility and generate password candidate lists. After 6 months of near-continuous attempts at 9 seconds per try, the method failed. The laptop remains usable without BIOS access, proving HP's security is fairly good, while demonstrating that AI assistance doesn't overcome fundamental security design. Community discussion provided historical context about 1990s AMI-BIOS systems where bypassing passwords required only a little patience and some Turbo Pascal, a reminder of how security has evolved. Technical infrastructure and security research. A significant privacy vulnerability in FreeMobile's free Wi-Fi secure service in France demonstrates how convenience features can harbor serious security flaws for years before discovery. Free Wi-Fi Secure allowed FreeMobile subscribers' smartphones to automatically connect to any nearby Freebox router broadcasting the network, using EAP SIM authentication, where the SIM card itself served as the authentication key. No passwords required, just seamless connectivity. The service was particularly valuable when unlimited mobile data was rare and expensive. The vulnerability emerged during unrelated testing with the Evil M5 project, a pen-testing gadget for Wi-Fi interception scenarios. The researcher noticed their own smartphone, with free Wi-Fi secure saved as a known network, leaked its IMSI, International Mobile Subscriber Identity, in clear text during EAP SIM authentication. Systematic verification confirmed this wasn't device-specific. The researcher's own Freebox, the Evil M5 project in replay mode mimicking different environments, and friends' devices all exhibited identical leakage. The implications were severe. Passive attackers could capture IMSI values, enabling user tracking, correlation across sessions, and potential exploitation through telecom protocols like SS7. The discovery led to responsible disclosure and ultimately contributed to the service's discontinuation, hence the article's title. The Evil M5 project itself represents the dual-use nature of security research tools. Compatible with CardPuter, Atoms 3, Fire, and Core 2 devices, it enables scanning, monitoring, and interacting with Wi-Fi networks. The project explicitly states it's designed for educational purposes in controlled environments, with the creator disclaiming responsibility for misuse. Features vary by firmware but include network scanning, port scanning, and various wireless protocol testing capabilities. The case illustrates how hobbyist security research with accessible tools can uncover vulnerabilities in production infrastructure that formal security audits missed. For those working at even lower levels, reference material on x86 instruction encoding, specifically the complex interactions between prefixes and escape opcodes, provides foundation for understanding how processors decode instructions. This kind of architecture-level knowledge becomes increasingly relevant as AI systems push toward hardware optimization and custom inference implementations.